This is a walkthrough of Problem 1 on Exam 2 of Module 10 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1. A laser is shot horizontally into an isosceles flint glass prism. It has an index area refraction of 1.65, and an apex angle of 30 degrees. Enters the prism high up on the face. It gets refracted when it comes into the prism. What is the direction of the beam relative to the horizontal after it enters the prism? And then it's going to exit the prism on the other side. State whether it's above or below the horizontal, and the number of degrees relative to the horizontal, to 3 significant digits. We need a good normal to start off. As always, let's put that in. The bottom angles are 75 degrees each, because the total has to be 180. The angle between the horizontal beam and the prism face must be 75 degrees as well, right here. That's 75. If that's 75, this is 15 degrees, the angle from the beam to the normal. So the incident angle from the normal is 15 degrees. If you're not careful and you want to put a number in as fast as possible, you might assume that's 30 degrees, the apex angle, but that would be wrong, and it's tough to recover from a mistake like that in the very beginning of the problem. It pays to be careful in the beginning. The incident of angle in the air is 15 degrees. We can use Snell's law. Medium 1 is the air. Medium 2 is the flint glass. Air is 1, has index of refraction of 1. The angle from the normal is 15 degrees. Flint glass is 1.65. We can calculate theta 2. It's 9.02 degrees. We can draw the beam in. And remember, the 9.0 degrees, 02 is from the normal. So let's put that in as well. That small angle right there is 9.02 degrees. The question asked for the angle of the beam from the horizontal. So let's draw the horizontal. And we know that the angle between the normal and the horizontal is 15 degrees. The whole angle is 15 degrees. Between the beam and the normal, it's 9.02. So we can calculate between the beam and the horizontal must be minus 9.02, which is 5.98. So the beam is about 6 degrees below the horizontal. And that's part A. Now we can address part B, what happens at the second interface. To start, we draw the normal. There's the normal. We need the angle between this beam, the beam in the prism, and the normal. There's a number of ways to get this. Let's focus on this triangle here, made by the 2 normals and the beam itself. This small triangle right in the middle. The angle between the normals is 150 degrees. We can get that by considering this quadrilateral. The interior angles of a quadrilateral must add to 360. So the 2 normals are 90 each, that's 180. The apex angle is 30. 180 plus 30 is 210. So this must be the rest of the 360, and that's 150 degrees. So we have a 150 degree angle between the 2 normals, and we have 9.02 right here. We can calculate this one. It's 180 minus both of those, which is 20.98 degrees. So the angle of incidence for the second refraction is 20.98 degrees, and we can use Snell's law again. It starts in the glass, 1.56, times the angle from the normal in the glass. In the air, it's 1.00, and then we have theta 2. We can calculate theta 2 is 36.20. So that's the angle from the normal in the air. And since it's going from glass to air, it bends away from the normal. It's a bigger angle, so let's put that angle in. But the question asks for the angle of the beam from the horizontal. Let's draw another horizontal. We know that the angle between the normal and the horizontal is 15 degrees. So the angle between the beam and the horizontal is 36.20 minus 15 degrees, which is 21.2. So the answer to part B is 21.2 degrees below the horizontal. That's problem 1.